August 1958. The third concept was to mount the 90mm T-208 smoothbore main gun and the T-95E6 turret with the T-6 cupola of the T-95 tank. It never progressed beyond design drawings. The fourth used the T-95E1 turret and the T-208 main gun. A mock-up was built using the new Vision cupola. All of these conceptual designs were referred to as the M60. A contract was awarded to Chrysler Engineering in September 1958 for the Advanced Production Engineering (APE) of the M60 Concept #2. The T-95 hull was considered, however its one-piece front casting was too difficult and expensive to produce in quantity. Some existing T-95 hulls were refitted with the AVDS 1790 engine and used from 1960 to 1964 to develop the T-1181 prototyping of the M728 combat engineer vehicle. Instead, the decision was made to use modified M40A2 hulls. The hulls had 3 return rollers and 6 steel rotor wheel pairs per side with no shock absorbers, using only bumper springs on the first and 6th rotor wheel arms, along with a widened turret well and ring, and a flat wedge-shaped glacis. The T-254E2 gun was chosen to be the main weapon of the tank in August 1958, being standardized as the M68 105mm gun. After a briefing on the 11th of December 1958, General Maxwell Taylor ordered the M60 into production because of the improvements it offered in firepower, protection, and cruising range. Since the tank had not yet received its official designation, these prototype hulls were briefly referred to as the M68 in December 1958 until they were officially named the M60 in March 1959. Fulfilling this requirement was an interim tank design that resulted in the M60 series, which largely resembles the M40A2 pattern it was based on, but has significant differences. The visual similarity of these designs as well as their overlapping period of service has caused some sources to informally name the original variant of the M60 as a pattern tank. M60 Series, edit. The OTCM, Ordnance Technical Committee Minutes, #37002 officially standardized the type as the tank, combat, full-tracked, 105mm gun, M60 on the 16th of March 1959. The production contract was approved April 1959 with the low-rate initial production starting in June at the Chrysler Corporation Delaware Defense Plant in Newark, Delaware. Production Pilot 1 was completed at Chrysler Defense Engineering on the 2nd of July with an initial production total of 45 tanks in July 1959. These tanks were sent to the Aberdeen Proving Ground for survivability testing and final design modifications. This batch of tanks did not have the M19 cupola due to its initial production problems. Production Pilot 2 was finished on the 4th of August and used to develop technical publications, and an additional 47 tanks produced to complete the first low-rate production buy. In August 1959, an engineering bid package was awarded for the second low-rate production buy of M60s to be built at the Delaware plant. Production Pilot 3 was completed the 2nd of September. These tanks went to the Detroit Arsenal Test Center for maintenance evaluations. They were then sent to Fort Knox for user trials. The fourth pilot was completed on the 26th of October and was used as the master hull to verify production standards at the Detroit tank plant with a low-rate initial production total of 180 M60s built in 1959. Subsequent production, starting with the October 1960 batch, were built at the Detroit Arsenal tank plant in Warren, Michigan. It reached operational capability with fielding to Army units in Europe beginning in December 1960. Features. The original variant of the M60 series ultimately was produced as a quick-fix engineering QFE upgrade of the M48 due to the Soviet Union's tank advancements of the late 1950s and the delays from developing the Silica's armor and an improved turret design. The M60 mounted a 105mm M68 main gun with the bore evacuator mounted towards the middle of the tube, carrying 57 rounds in the clamshell-shaped turret style of the M48. 9 rounds were stowed in the left side of the turret bustle behind the loader. The remaining rounds were stored inside safe containers on the hull floor. A new short receiver coaxial machine gun was designed for the M60 tank. This was the 7.62mm M73 /T197E2, which replaced the .30 caliber M37 used on the M48A2. It had 2,000 rounds of ammunition. They had a reputation for jamming. After working to correct this, they were redesignated as the M73A1 in 1970. The electrical package on the M60 was essentially the same as used on the M48A2C, including an improved turret control system and an all-metric measurement M16 fire control system, FCS. The M16 FCS consists of a new M10 ballistic drive and mechanical M16E1 gun data computer, which integrated barrel temperature data with an M17 coincidence range finder. The range finder is a double-image coincidence image instrument used as the ranging device of the gunner's primary direct sighting and fire control system. The gunner is provided with an M31E1 day periscope with a magnification of x8 and an M105D day telescopic sight with a magnification of x8 and a field of view of 7.5 degrees. Range information from the rangefinder is fed into the ballistic computer through a shaft. The ballistic computer is a mechanically driven unit that permits ammunition selection, range correction, and superelevation correction by the gunner. The ballistic drive receives the range input and, through the use of cams and gears, provides superelevation information to the superelevation actuator. The superelevation actuator adds sufficient hydraulic fluid to the elevating mechanism to correctly position the gun. In late 1962, a kit was fielded that allowed the use of the N/VSS-1 V1IR searchlight. The searchlight has both infrared and visible light capabilities and was positioned over the gun. Along with an M32IR periscope for the gunner, M19IR periscope and M18IR binoculars for the commander provided first-generation night vision capability to the M60 and M60A1 tanks. This kit was also compatible with the M48A3/A5. The hull bottom had a strong boat-like appearance with a pronounced recess between the upper tracks and external suspension arms with cast aluminum rotor wheels and return rollers, along with a single shock absorber on the first rotor wheel pair. Cast aluminum road wheels were used to save weight. The armor was improved, at 6 inches, 155 millimeters, on the front glasses and mantle of solid rolled homogeneous armor, while it was 4.3 inches, 110 millimeters, on the M48. Power was provided by the AVDS 1790-2 engine, CD850-5 cross-drive transmission and the T97E2 track assembly as used on the M48A3. The drive sprocket is located at the rear of the hull. The vehicle also provides full NBC protection for the crew using the M13A1 protection system, creating a positive atmospheric pressure in the crew compartment. The positive pressure keeps contaminated air out and forces the smoke produced from firing the main or coax guns out of the vehicle. Access between the driver's compartment and the turret fighting compartment was also restricted, requiring that the turret be traversed to the rear. The M60 was deployed to West Germany to counter the threat presented from the T-54S and T-55S of the Soviet Union and Warsaw Pact, as well as to South Korea, but was never sent to South Vietnam, mainly due to unfavorable terrain and the general lack of significant numbers of North Vietnamese armor. In May 1961, Army Chief of Staff General George Decker announced that the European Command had been receiving the M60 to replace older tank inventory. By October, the 7th Army was outfitted with many of the tanks. A total of 2,205 M60s were built between June 1959 and August 1962. Some M60 forward/E60 tanks were later transferred to Israel and participated in the Yom Kippur War. Some were repurposed as AVLBs. M60A1 series, edit. Development. The program to develop the M60A1 was approved in early 1960 in conjunction with abandoning further development of the advanced composite armor and the closure of the T-95 medium tank project. The first proof of concept attempt to mate a modified M60 hull with the T-95E7 turret took place in March 1960. The turret, even without the siliceous cord armor, provided improved ballistic protection. Additional space for the turret crew was also made available by using the M140 mount, thus moving the cannon 5 inches forward. The first two prototypes, Pilot 1 and 2, were ready in May 1961 and the third, Pilot 3, in June 1961, when the vehicle also received its official prototype designation as the M60E1. These vehicles were built by Chrysler Defense. Pilot 1 was sent for evaluation at the Eglin Air Force Base climatic hangar, while Pilot 2 was tested at the Yuma Test Station, and Pilot 3 underwent field trials at Fort Knox. On the 22nd of October, 1961, the M60E1 was officially accepted in service under the designation of Tank Combat Full-Tracked 105mm gun, M60A1. Production began on the 13th of October, 1962, when the Army placed an initial order for 720 of the tanks for $61.2 million. Features. In addition to the new turret design, the hull was upgraded. The hull's upper glacis armor was increased from 3.67 to 4.29 in, 93 to 109 mm, at 65 degrees, while the turret sights went from 1.9 to 2.9 in, 48 to 74 mm, at their apex. This brought the frontal armor up to the same 10 line of sight armor standard of the M103 heavy tank. A mushroom-shaped fume extractor was placed at the rear left of the turret bustle to vent smoke produced from firing the main or coax guns out of the vehicle. The addition of a shock absorber on the second rotor wheel pair was also accompanied by a slight relocation of the first return roller. These modifications were needed due to the increased weight of the M60A1 turret as well as the additional hull armor. The ammunition load for the main gun was increased to 63 rounds. Round storage was distributed between the turret bustle, where 15 ready rounds of various types were stowed and accessible for the loader, and the rest were stored inside safe containers on the hull floor. The uncomfortable wire mesh seats for the loader and gunner were replaced with padded ones. The brake and accelerator pedal and gauges were also rearranged for more efficient and comfortable operation, while the steering wheel was replaced by a T-bar steering control. The engine and powertrain were supplied by the Continental AVDS 1790-2 engine and the CD850-5 cross-drive transmission, and using the T97 track assembly. Improvements to the electronics package for this version included an improved electromechanical traverse assembly and an N/VSS-1 V1 IR searchlight above the gun shield. The M19 FCS consisted of the M17 A1 coincidence rangefinder, M10 A1 ballistic drive and the mechanical M19 E1 ballistic computer for the gunner. The M60 A1 Rise passive tank uses the M60 E1 variant of the gun carried in the M140 mount. Most M60 A1 Rise tanks were retrofitted to this standard after 1977. The M60 E1 gun shares the same firing characteristics as the M68. It featured several design improvements including an updated gun hydraulic configuration, a stabilization upgrade for the gun, a gun elevation kill switch for the loader, improved ballistic drive and other component refinements. Upgrades. As the development of a new main battle tank stalled with problems and cost escalating quickly, the M60 A1 was forced to serve longer than originally intended, with production lasting almost 20 years. In that time span, numerous product improvement programs were put forward. As the major changes were incorporated into the production line, the vehicle model designations were changed. The first of which was top-loading air cleaner, TLAC, in 1971. This reduced dirt and dust ingestion, which increased engine life as well as allowing for easier servicing of the engine. Early TLAC panels were made from aluminum and were vulnerable to damage from small arms fire. Next came add-on stabilization, AOS, that was introduced in late 1972. This was an add-on kit made to fit with minimum modifications to the existing hydraulic gun control system. The add-on stabilization system provides stabilization control for both gun elevation and turret traverse. It provides the gunner with the capability of aiming and target tracking and also improved surveillance of the battlefield terrain by the gunner while the tank is moving. It may be used in any one of three modes of control: 1. Power with stabilization on, 2. Power with stabilization off, and 3. Manual. In the power with stabilization on mode, the gunner's aim on target is automatically retained while the vehicle is in motion. This mode provides a fire-on-the-move capability. The power with stabilization off option eliminates needless exercise of the stabilization system and provides a backup power mode. The manual backup system permits the crew to aim and fire the weapons should the electrical forward/hydraulic subsystems fail. At a range of 2000 m, 6,600 feet, hit probabilities of better than 70% from a moving M60 A1 were obtained in Aberdeen test results, while without a stabilizer it was essentially zero. M60 A1s with this upgrade were designated as the M60 A1 AOS. The T142 track was fielded in 1974, which had replaceable rubber pads, better end connectors, and improved service life. M60 A1 AOS Plus was the denotation for M60 A1s equipped with the TLAC and AOS upgrades and the T142 track. Introduced in 1975, the reliability improved selected equipment, RISE, was a comprehensive upgrade of the M60 A1 hull as well as integrating the previous TLAC and AOS upgrades. It included the upgraded AVDS 1790-2C Rise diesel engine and CD850-6 transmission that featured several changes in order to improve service life and reliability. A new 650 ampere oil-cooled alternator, a solid-state regulator and new wiring harness with more accessible disconnectors was also incorporated into the hull's electrical system, as well as armored steel TLAC panels and the return to the use of steel rotor wheels and return rollers. They were denoted as M60 A1 Rise. The 1977 fielding of the passive M32E1 sight for the gunner and M36E1 periscope for the commander, as well as the M24E1IR night vision block for the driver, provided second-generation night vision capabilities for M60A1 and RISE tanks. These new passive gunner's sight and commander's periscope provide recognition capability at longer ranges and at relatively low night light levels, a half moonlight. Under starlight conditions, they will provide recognition beyond 500 m, 1,600 feet, with the use of an IR searchlight. During 1978, kits for the mounting of the M239 smoke grenade launchers and the mounting of the M240 as the coaxial machine gun were fielded. The development of the M735 APF's ammunition required a cam update to the gun's mechanical ballistic drive for accurate firing. M60A1s configured to this standard were denoted as M60A1 RISE Plus. The M60A1 RISE passive featured the implementation of all previous updates plus an /VVS2 passive night vision block for the driver, a deep water fording kit, the capability to mount explosive reactive armor, ERA, and the AVDS 1790-2D RISE engine with CD850-6, a transmission and a vehicle engine exhaust smoke system, VESE, that visually obscured the area around the vehicle. The VESE smoke screen system does not provide protection against infrared, thermal or laser detection. The two 6-barreled, electronically fired M239 smoke grenade launchers, one on each side of the main gun and replacement of the Coax machine gun with the M240C, were implemented in late 1978. The smoke grenades contain a phosphor compound that masks the thermal signature of the vehicle to the enemy. They were denoted as M60A1 RISE passive. Over the period of M60A1 tank production, several essential engineering changes were incorporated. Many of these miscellaneous changes were to improve the system's safety, reliability, maintainability and increase mission performance. The M60A1 Tank Hull /Turret Product Improvement Plan, PIP, update kit includes those items that could not be readily identified with basic major product improvements and to incorporate essential engineering changes that had occurred during M60A1 tank production. The update program included engineering changes and minor product improvements which were not part of specific product improvements, but were required to upgrade early vintage M60A1 tanks up to the current M60A1 RISE production configuration. Additionally, the hull PIP update kit was applied to the M48A5. The M60A1 was in production from October 1962 until May 1980 and was extensively used by the U.S. Army and Marine Corps, as well as being widely exported to foreign governments. A total of 7,948 M60A1s, all variants including E60A, were built. Many of them were later converted to the A3 standard. M60A2 series, edit. During the early 1960s there was some debate regarding the future of main tank weaponry, largely focusing on conventional kinetic energy rounds versus missiles. In the early 1960s it was generally accepted that the maximum effective range of the M68 gun was between 1,800 and 2,000 m, 5,900 and 6,600 feet. The XM-13 missile system had proven itself viable, obtaining over 90% first-round accuracy up to 4,000 m, 13,000 feet. But the development of a main battle tank variant was bogged down by having too many design proposals. In response, studies were made in August 1961 to retrofit existing M60 tanks with a weapon capable of firing both conventional heat, high-explosive anti-tank, rounds and launching ATGMs, anti-tank guided missiles. 3 M60E1 tanks with T-95 turrets were modified to permit the installation of the 152mm XM81 gun launcher. Mounted on former M60 hulls, they were to provide test beds for the evaluation of the Shillelagh weapon system. Although this system was the preferred armament for the MBT-70, by late 1961 problems with the XM-13 missile required that the program be reorganized. The missile was reclassified as an applied research project, and it was obvious that there would be some delay before it would be available for service. On the 10th of January, 1962, representatives from various ordnance organizations met at the Ordnance Tank Automotive Center, ATARC, to review armament systems that might be suitable replacements, if the Shillelagh missile could not be developed in a timely manner. Time was particularly critical for the Armored Reconnaissance Forward/Airborne Assault Vehicle, R/AAV, the XM551 Sheridan, which required a decision on the armament by April 1962. The possible delay was not as serious for the MBT-70 since the program was limited to conceptual design and component development. The requirements also differed for the tank because of its ability to carry a much heavier weapon system. Several backup weapons were also under consideration, and concept studies were prepared showing their application to the MBT-70 concepts. The 152mm gun launcher XM81 also was considered without the missile, depending only on the combustible case conventional ammunition. It was expected that the Shillelagh or some other missile then could be introduced at a later date. The 105mm gun M68 as standardized for the M60 tank was considered as an alternate armament system. It had the advantage of being immediately available, and its ammunition was already in production. Of the several turrets drafted, one of the earliest was the driver-in-turret integrated fighting compartment. This design was further developed using the MBT-70. Another proposal was a more compact turret design of the T-95E7. Development. During the development of the M60A2, 3 different turret types were considered: the Type A, Type B and Type C. The Type A turret would be constructed based on the T-95E7 turret and then further modified and produced as the Type B standard. The Type C turret was essentially a larger M551 Sheridan-style turret. A mock-up of this turret was built, but the design was never seriously considered and soon abandoned. All of these conceptual variants were referred to as the XM66. On the 10th of January, 1964, the Army reviewed all 3 variants and selected the Type A variant for further development. Initially 2 Type A turrets were built in 1964. The M60A1 hull was used starting in 1966 to develop the new compact turret design using the 152mm M162 forward/XM81E13 rifled barrel main gun. These developmental tanks were designated as the M60A1E series. The M60A1E1 referred to vehicles based on the modified T-95E7 Type A turrets with M60 hulls used through 1965. The M60A1E1 variant was used to evaluate the XM81 dual-purpose gun and its compatibility with the XM13 guided missile, armor defeating together with the XMT-M51 training round. During the early testing of the XM81 main gun, it was noted that misfires and premature detonations of the M409 conventional case ammunition were caused by unburned propellant in the bore and breech. This flaw was often catastrophic as it set off the projectile in the barrel as it was fired. To remedy this, the guns were equipped with a traditional fume extractor on the barrel. The XM81 gun forward/launcher also experienced frequent faulty breaches, often not closing correctly during a missile firing, allowing the exhaust of the launching chiller to vent hot noxious gases into the crew compartment. As the M60A1 hull became available in 1966, it was decided to upgrade these prototype vehicles to the M60A1 hull standard. Vehicles using the M60A1 hull and chassis received the M60A1E2 designation, and were used to develop the Type B compact turret and the XM81E13 gun variant. The M60A1E2 finalized the turret design with the use of a compact turret which reduced exposed frontal area by 40% compared to the